Monday is done. Radicals are vamoose. Tuesday is here, and therefore so is a new chapter. We're going to be dealing in pre-algebra with area and volume in this chapter. Number 13, if you're following along in your book, chapter 13, remember to take good notes because just like you did on your last test, you can use your notes. Remember, guys, to get your quizzes done, number 1, because they constitute about half of your grade. Okay, so make sure, number 1, you have them turned in. Number 2, make sure you made all corrections that I told you to make on those quizzes. I've gotten very few corrections back because I'm taking 100% credit of all corrections because of the extenuating circumstances that we have. So make sure that you get that done and get those to me. And then when you have perfect or near perfect quizzes, you also get to use those on your test. And usually what you find on your test is 90+% of what you've already had on your quizzes. So it's really to your advantage to do that. Let's get in without further ado to area and volume. I think you guys are going to enjoy this chapter. I believe it's a little bit of a breath of fresh air after the difficulty of what we had last chapter. And in section 1 of chapter 13, we will be dealing with finding the area of parallelograms. What are parallelograms? Parallelograms or quadrilaterals have sides that are parallel to each other on the top as well as on the bottom. Or they run the same as one another. Quadrilaterals, quad, 4, right? You have 4 sides, each side has something that runs laterally or alongside it. So they're the same concepts, parallelogram or quadrilaterals. And I'm going to give you 2 important formulas. Make sure that you write these down, boom, just like that. And I put those in red so they really stand out at the top left and the top right of the board, respectively. Write down the area for a square. And of course, a square is when you have 4 completely, perfectly even sides. You know that. The formula for a square, finding its area, is A equals one of the sides, doesn't matter which one because they're all 4 identical, and then square that side or multiply it by itself. Okay, that's not one side times 2, remember, but that's an exponent of 2, meaning you square it or you multiply it by itself. The second formula that you need to write down is the same for if you write it this way, I might ought to add, is the same for a rectangle as it is any other parallelogram or quadrilateral. By the way, a square and a rectangle, and you know this is what a rectangle looks like, 2 completely even straight sides, 2 completely even straight sides on the other side, but these 2 sides are not equal necessarily to the others in a rectangle, although technically it gets kind of confusing because a square is technically a rectangle, but not all squares are rectangles, right? Because there are some that all 4 sides are not exactly the same. Now, both squares, if I get out of the way here, both squares as well as rectangles, they are both parallelograms or quadrilaterals because on this side you have one that runs just right alongside or parallel to it. On this lateral you have another side that runs right alongside it, and you have a total of 4 sides, and so it fits the definition, and a square is the same thing. It fits the definition, and so does a rectangle of a parallelogram or a quadrilateral. However, there are some parallelograms or quadrilaterals that are not rectangles and are not squares. You see how these get slanted? Okay? And if you see them like that, with those slants to them, they're still parallelograms, they're still quadrilaterals, however, they're not rectangles. And the reason for that is the height, which turns it into a rectangle, is going to be shorter than what the length of those sidelines actually are. And that's the difference between the 2. Anyway, getting back to the formulas though. The formula for the area of a rectangle, we typically know it as A equals LW, or length times the width. And that's okay for a rectangle, but if you want just to have one formula for both, you could remember it this way. A equals B, which is your base, times your height. Okay? Your base times your height. Now we would look at this as your width times your length, and that's okay. But I say it that way because the formula A equals base times the height, or B times H, works for any parallelogram or quadrilateral, including a rectangle, including a square. Okay? But look, whenever we get to this one, we're not there yet, but on number 2, whenever we get to this one, again I would say the parallelogram, what we have normally recognized as the width on a rectangle, it's not the same thing as the height. Okay? So, but those are the 3 formulas. Make sure you have those down. And for right now, let's back up over here to 1A and let's just talk the most basic of shapes, or one of certainly, in figuring the area, probably the easiest, and that would be a square. So for 1A and 1B, I didn't write what we're trying to find like I did on the right side of the board, because both of these are understood to be area that we're trying to find. So 1A tells us to find the area of a square that is 4.2 centimeters on one of its sides. Okay, what do I do with that information if I'm trying to find the area of a square and 4.2 cm is one of its sides? Well, the first thing I want to do is write my formula for a square. What is that? Let me straighten up my equality sign a little bit here. What's the formula for a square, the area? A equals S, any one of the sides, because they're all exactly the same, squared. Okay? And I'm trying to find area, so that variable A is going to remain, what's going to turn into a number is S, because I'm given one of the lengths of the side. And that length is the number 4.2. And remember, whenever I plug in a number for a variable, I always want to put that in parentheses. This case is not going to make a difference, but in some cases it does. So make sure that you do that just as a good rule of thumb. Don't forget though, your squared, your 2 as an exponent. And remember guys, this is not 4.2 times 2. Rather, this is 4.2 times itself, which is 4.2. Guys, get out your calculators. I'm going to let you use your calculators on this chapter. And we wouldn't have to do it. It's not a huge number, but I'm going to let you speed up the process on these, because I know we could sit there and do the math, but we've done that all year, so we'll speed it up on these. So I'm going to put in 4.2, and if you have an exponent button, you can put that or just square it. I'm going to, for simplicity's sake, like I have been doing some, I'm just going to put times 4.2, which is itself. So it's not 4.2 times 2, but 4.2 squared, which is 4.2 times itself, which is 4.2. And that equals 17.64. So I'm going to punch in here, or I'm going to write in here, I should say. I already punched on the calculator. A equals 17, what was it I said? 0.64. I was thinking 0.62, but that doesn't sound right. Okay, 17.64 is my area. Number-wise, I'm already done. You like this? That's easy, isn't it? I think you'll like this a lot better than what we were doing before. But don't forget, we're not done answering because we haven't labeled units. And what units, with what units were we working? Centimeters, which is just cm, no period. But listen guys, whenever you find the area of something, your unit in the end, now not your number, we've already done that stuff, but your unit in the end is going to have a 2 above it, which means squared, centimeters squared. Now again, that's not going to apply back to your number here. We've already done that. But it's 17.64, not centimeters, but centimeters squared. The side, all the sides themselves are just centimeters as a single unit, but when you calculate the area using those single units, you end up with centimeter, in this case, centimeters squared. If it were meters, it would be meters squared. If it were feet, it would be feet squared. Okay, it doesn't matter what the unit is, it's always going to be squared when you're dealing with area. I know we're not there yet, but as a heads up, whenever we start working with volume, that's cubed. It's going to be units cubed, so it'll be centimeters cubed, feet cubed, meters cubed, etc. But for right now, area, all we need to know is it's measured in units squared, or units, what we would understand to a second power. Okay. All right, 1B. Find the area of a rectangle with sides of 8.5 inches and 4 inches. Let's underline our significant points of information. We want to find the area of a rectangle, and we have sides, and one of those sides is 8.5 inches and the other side is 4 inches. Okay, so what I want to do is come right up here, and I can use for a rectangle, you can write it either way, it's no different. You can write A equals BH or A equals LW. Alright, whichever you prefer for a rectangle, I don't care, it doesn't make any difference. I'm going to spice it up a little bit because it's so easy. And I'm going to use what I don't usually use. A equals BH. Because I kind of fall asleep if I do the same thing 10 million times, but the same way. So, let's do A equals our formula, okay? One side, B times the other side, H. Since I'm trying to find area, that variable is going to remain my equal sign. And the base, it really doesn't matter in what order you write them. Maybe technically, okay, a base we might look as the shorter side. So let's say 4. But really, again, it doesn't matter in what order. Okay, we're just multiplying anyway. 2 sides times each other, 4. And the other side is 8.5. Okay. Now I can do this one in my head. You can do this one in your head too. 4 times 8 is 32. 4 times 0.5 is 2. And so 32 plus 2 is going to be an even 34. Alright? Again, if you want to punch that in your calculator, that's okay. I won't hold that against you. So 34, but in what units am I measuring? The 2 sides were in inches, but since I found area, my units are inches what? Always, whatever unit it is, inches squared. Don't you like this stuff? Man, this is easy peasy, isn't it? This is lemon squeezy. This is the good stuff in relation to what we were doing. That's good. We need a little bit of a break after that tough chapter. Number 2, find the area. Notice this is not a rectangle, but find the area of a parallelogram. And you can tell it's a parallelogram because the sides are not straight up and down, but they're tilted. They're at an angle, and that kind of puts everything at a strange angle. What I do formula-wise to find the area of a parallelogram is I use this formula, same one I did down here. A equals B times H. So write that right off the bat. Okay? What is my base going to be? Alright, what's my base going to be? My base is going to be the spot on which it's lying, okay, and that can be on the shorter, as we figured earlier, but that can be on the longer of the 2 possible sides as well. And so since it's resting, alright, it's resting on this side, I'm going to use, trying to find the area, so my variable remains A equals, I'm going to use 12 as my base. Now, how do I know which number I use for my height? Because I have 8 and I have 6.6 m. Your height is whatever's straight up and down. It's not the one that is slanted. In a rectangle, it doesn't make any difference because they're exactly the same. Okay? But in a parallelogram that's not a rectangle, and is not a square, it has those slanted lines, then you're going to have little dashed lines, and those little dashed lines that are straight up and down are going to tell you your height. So the number you're going to use for height is 6.6, and do not use 8. They just throw that in to try to confuse you, okay? Use the little dashed line that's straight up and down, not the one that's solid and that has the curve to it. So it's going to be 12 times 6.6. Now, I want to show you something and why this works. This is just like a rectangle, and here's why. If you can envision this, you can take this triangle, okay? You can take that triangle and you can fit that right there, okay? Take this triangle and that slanted line and fit it right there, and that's straight up and down, and then that's straight up and down. Can you kind of see that? Does that make sense? And maybe it's difficult to envision, but you can take that triangle sliver and that dashed line makes it a straight up and down line, and then this triangle fitting in over here with that sharp cutoff as well makes it a rectangle. It makes it a rectangle, really, is what that does, and that's why you can use this formula, and it works just like the formula for a rectangle if you use the height and not the actual length of one of the sides. So anyway, what I need to do is just some simple math now, guys. Just multiplying two numbers together. So we could do that in our heads. It's large enough. We're not going to waste our time. And so I'm going to punch in 12 times 6.6. All right, what is 12 times 6.6? That is 79.2. 79.2. And so my A, or my area of that parallelogram, equals 79.2. Now notice what my units are, M and M. So my units are M, but I just found the area, so M, or meters what? That's right, meters squared. Units are always that way. Very good. Let's just do one more. What do you think? You guys like math lessons with 3 problems? Oh, that's beautiful. We'll see if we can keep more like that now. All right, number 3. If I have a rectangle in which the area is given to me, this is different. An area of 75 meters, notice squared, and squared because it's area, and I have a base of 6, what is my height in that problem? Well, here's what I'm going to do. I'm going to write down my formula, first of all, for any parallelogram, including a rectangle, which is A equals BH. And in this case, we can even do LW, because it would be the same thing with being a rectangle. But A equals BH. Okay, my base, or the ledge on which it's standing, the side. Okay, and then my area, but I need to plug in what information I have. I'm trying to find height, so H is going to remain. I don't know what that is. It's going to remain as my main variable. But this time I have the area, which is 75. So I'm going to plug in 75 for A. That's different than what we've done so far. Equals B, which I know to be 6, so I write 6 in for B. Okay? And if you want, we can go ahead and put it in parentheses. We don't have to, because it's going to be multiplied anyway. To H, we don't know what that is. That's what we're trying to find. And guys, look, I'm trying to solve for H, but I have a 6 that's attached to that H. And how is it attached? Via what mathematical process? Understood that there's an invisible multiplication sign there. So how do I undo that multiplication that's being done between that 6 and that H? I just divide both sides by 6. And when I do so, I'm going to have, I can do that in my head, I think. I want to say that's going to be, let me see here. I want to say it's going to be 12 1/2. Let's see if I'm right on that. Okay. Let's punch into the calculator. All right, where are we? Here we are. 75 divided by 6. Woo! 12 1/2. The reason for that, I know 12 times 6 is 72, with a leftover 3, and 3 over 6 is 1/2, and 1/2 is 0.5. So, or 1. Or as I said, 1/2. So, okay. So my H is 12.5, or 12 1/2. Okay, and I would do it decimal when you're doing calculations of area and volume. So 12.5. Now, in what unit is that measured? Well, I didn't write up here. I should have. I probably just left it off and copied it down. But I started with meters squared and meters. And since I'm just dealing with a side, and I did not calculate the area, but I went backward really from area, I just have as a unit M, not M squared, because I did not find the area. I used the area, but I didn't find the area. And so H is going to be measured just in meters and not in meters squared. Okay, guys. What do you think about that? Not too bad, isn't it? That's all that I have. Area and volume. I think it's going to be a good chapter, and I believe we already have down the areas of parallelograms. I will see you soon, boys and gals.